Okay, I want to take a minute to answer a couple of questions that one of the students raised. The first one is that the expression x squared plus 144 somehow was said to be prime, but they thought that it could be factored in this way, that x squared plus 144 is equal to x plus 12 times x minus 12. And the important thing to note here is that there is no formula for a sum of squares. But there is a formula for a difference of squares. So, and the difference of squares would have been x plus 12, x minus 12. So if it had said x squared minus 144 is equal to the x plus 12 times x minus 12, that would have been correct. And that is not prime, but x plus 144 is prime. Okay, so that's the answer to the first question. And you can pause and rewind this video if you need to. I'll go on to the second question now. And that question is it possible to bring index cards with notes on them, notes and formulas? And yes, you can bring 2 index cards with notes, one for each chapter. Okay, and I will go on to the next question. And that is, will there be word problems, geometry applications, etc.? I have only one word problem, one geometry application on the test, and that references triangles. So really the only formula that you'll need is that the area of a triangle is 1/2 of the base times the height, and the height is also called the altitude sometimes. Okay, that's the next question. I'll go on from there. Alright, the next question is, I guess there is some confusion. Normally, when we have a trinomial like x squared plus 4x plus 5, or let me make that x squared minus 4x plus 5, usually we're looking for two numbers that multiply to give you the last number, but add to give you the middle number. And sorry, I'm going to make one more change. So it's going to be x squared minus 4x minus 5. And we'd be looking for two numbers that multiply to give you negative 5, but add to give you negative 4. And in this case, those numbers would be positive 1 and negative 5. They multiply to give you negative 5, but they add to give you negative 4. And we would finish up the factoring like that, x plus 1 times x minus 5. Well, the question is, well, what happens over here with 7x squared minus 19x minus 6, where the two numbers, you don't find the two numbers that multiply to give you 6, but add to give you negative 19. Because when you have a number in front of the x squared, you have to do this differently. When you have a number in front of the x squared, you have to do it this way. You're going to multiply the first and last numbers, taking care of the sign, and that would give you negative 42. Now, you have to find two numbers that multiply to give you negative 42, but add to give you negative 19. And since the two numbers multiply to give you a negative number, one has to be positive, one has to be negative. Since they add to give you negative 19, the larger number has to be negative. So I start making a list of numbers that multiply to give me 42, and I'm looking for a pair that also add to give me negative 19. So I start with 1 and negative 42. Again, the larger number has to be negative, but that doesn't add to give me negative 19. The next one would be 2 and negative 21, and that does add to give me negative 19, so those are my numbers. So then I use those two numbers to rewrite the middle term, and I get something like this: 7x squared plus 2x minus 21x minus 6 equals 0. And you notice that I didn't change anything. 2x minus 21x is still negative 19x, as in the original problem. From this point, I use factor by grouping. So I factor out the greatest common factor from the left pair. I factor out the greatest common factor from the right pair. Then I factor out this new common factor of 7x plus 2, and that leaves me with two values of x equals 3 and x equals negative 2 over 7. So that's the way you have to solve those problems where there is a value in front of the x squared.